In this video, I'm going to be having a look at how we can deal with force vectors and how we can apply them to our components. Here we have a simple plate of steel, and what I would like to do is apply a force that is clocked at 30 degrees from the vertical, so pointing up from the surface this way. So in order to do this, first of all, I'll click Static Structural and apply a force to this surface. Apply. Now we're going to click on Components. Okay, so the magnitude of my force is actually 1,000 newtons that I'd like to apply. So what I can do is resolve the force to work out the components. So in the x direction, that would result in 500. However, we need to have a look at the direction of the coordinate system. So plus is that direction. I actually want it to go minus. So this needs to be minus 500. And then y will be 866. Okay, and so we can see we've now got a force, and that will be clocked at 30 degrees. Now what we can do is solve this. Okay, so if we have a look at the stress, we can see stress distribution, the direction, okay. You can see that it's pulling the sample in the direction of the force, so the results look good. We can also have a look at the shear stress distribution. Now there is another way in which we can do this. So if I click on static structural, what I'm going to do is click duplicate. So what we have here is another static structural solution. So it uses all of the previous information, so the mesh and the geometry, but what we've got is that we can change the boundary conditions. So we can keep the results from our previous one and the boundary conditions, but we can actually change them and do something different for this version. So what I'm going to do is actually remove this force. So I'm going to right click it, just go delete. We can add forces by adding our own coordinate systems to our components. So if I click coordinate systems here, you can see I can add a coordinate system. It's saying add some geometry, so I can tell it where I'd like it to be focused around. So I'm going to click this top surface, apply. Okay, so we can see we've just added the coordinate system onto that top surface. Now what I would like to do is rotate it around the z-axis so that it's similar, so that it's exactly the same as when I used the components before. So if I rotate around z and then say 30, we can see that the y is now being offset by 30 degrees about the z-axis. Okay, so what we're going to do is just rename this. So we just right click, rename. So 30 deg z-axis. Okay. Now if we come back to static structural, I'm going to click force. I'm going to select a top surface, click apply. And here we're going to click component again. But this time it says coordinate system, global coordinate system. I'm going to change this. So I'm going to pick the 30 degree z-axis. Okay, so we're going to use this coordinate system now for our components. And that means that in the y, I can type 1,000. Okay, and so this should be equivalent to the test that we ran previously. So if we solve this, we can have a look at the solution. Let's square the view up. Equivalent stress, deformation, and shear. Now if we compare these results, so the maximum here, 8.7. What's the maximum here? 8.7. Total deformation, 0.01. Total deformation, 0.01. There's actually no difference, okay? Shear is also minus 1.06, minus 1.06. Okay, so these are two ways in which we can apply forces. This should be really useful for you for completing task 3 of your assignment.